Hello everyone and welcome back to Intro to C course MCS 1142. So today is week 1B, which is the second session of the first week of semester summer 2021. So today, and according to the syllabus, we will be going over Visual Studio as part of setting you up to then start learning how to build programs and create your own software. So this is the syllabus on Canvas week 1B, which is May 20 today. So we are going to assume, let me go over this first. So know your peers, thanks for everyone who posted. Nice to meet each and every one of you. So we are going to assume that all of you have Visual Studio installed on their computers. So if you don't have it, you must inform me or the help desk in order to install it, since it's going to be the main platform for this course and future courses. And without it, you won't be able to proceed. So therefore, in case you don't have it, please make sure that this would be the first thing for you to do. So go ahead and get it, then proceed with watching the lectures. So I have Visual Studio. This is the icon, and I have Visual Studio 2019. I'm gonna go ahead and click on it. So you're gonna see this page. This is the startup page. This section is all the projects, the most recent projects that you created and opened on your computer. In my case, I only have one project, and it was at this date. I don't have any other projects. So I'm going to walk you over Visual Studio in general, each part, each section of Visual Studio, and how to run it, how to work with Visual Studio. Here you have several different sections. You have a clone repository. Clone repository, this section is mainly for version control or version management. There are many tools that keep track of all the changes that happen on the code on your project or a program. For example, Git. Git, which is written like this, Git. Git is a version control tool. So it keeps track of who did what on the code and when to the code. For instance, imagine there is a team of developers working on the same project, same program. So you as a team leader or you as just a developer, one of those team members, you would always want to go and see the history of changes and see who submitted code changes and when did these changes occur, so you can review them or maybe debug the code. Maybe someone made a change in the past and now you want to debug that code. You want to see what happened, why now we have a bug, what happened, what are the changes, or for many reasons. You will always need to track your changes. So with that being said, in order to share your changes or and allow yourself and others to view the changes and the history of of those changes, the program must live on some sort of a cloud or a server or a host that can be accessed by anyone, right? Can be accessed remotely from any computer by anyone. So cloning a repository, for example, I have this program, this lives on my computer. It lives on C, users, desk, da. In case if in an enterprise company, in a more professional company, you cannot trust local computers. So what if the computer breaks down, right? So the code must live on a host. So cloning a repository means there is a project that lives somewhere and you would like to download, let's call it download that code, download that project so you can work on it. Of course, if I click on it, it's gonna take me through the steps on from where would you like to obtain the code, and who are you, what's your login information, are you authorized to log in or to view or to download that code or that program. Open a project or a solution. This is local. Open a local Visual Studio project, just similar to this, but if it is old enough that it doesn't show in this list, I can I can click on this option and then navigate to that folder, wherever the solution is or wherever the program is or project is, and then I can open it in Visual Studio. That's for open projects. Um, for opening a folder, it is similar to opening a project, but it's a little different that when you select a project, it opens all and any project under that tree, under that folder. Example, when you in any browser, when you click to upload, usually the dialog that opens allows you to select a file. If you double click a file, you know the difference between a file and a folder. So this is a folder, this is a file. So for example, if I go to scan documents, so this is a folder and it has files. A folder might have another folder. So when that dialog opens to select what you are trying to upload, when you double click on a folder, it doesn't upload that folder. It opens that folder, right? When you click on a folder, it opens that folder and allows you to check what's in that folder. But whenever, on the other hand, whenever you double click a file, it uploads that file. So open a local folder allows you to actually select a folder instead of a file. So that's for opening a local folder. For the majority of your student life, you will always be doing this step, which is create a new project. You are always going to open Visual Studio, start from scratch, start from an empty project and build your program from scratch. Now you can always go back to some older projects and build on top of them, or maybe borrow a code from your previous homework, for example. That's fine, that's fine. But the majority of the time, you are going to create a new project. You're going to create a folder and say homework 2, for example. Then create a project inside that folder and call it a homework 2 program. Then go from there. So at any point in time, you can always go back to your previous projects that are organized by homework name or homework number or a project number or test. Review your code, study for your next test, etc. So I'm gonna go ahead and click it. Then I have this dialog. This dialog will show all the targets and languages that Visual Studio supports. Remember, there are many, many, many programming languages. There is like if you think there is only 10, uh, that's not even close. If you think there are 200 programming languages, that's not even close. Try and Google it. Actually, let's Google it. How many programming languages are there? There is many. 700. There are 700 programming languages. A programming language is a tool. So whatever job you have, let's say you work in construction, it depends on the job you're trying to do. Then you pick the right tool to perform that job. Let's say I want to make a hole in a wall. If I'm a construction guy and I'm trying to make a hole in the wall, how many ways I can do that hole? There are many ways. Are they all practical? Are they all efficient? What is the best way to do a hole in the wall? The best way to do is to pick a drill and drill a hole. So you pick the right tool for the right job. If you pick the wrong tool for the job, for example, let's say I grab a hammer and I start hammering the wall. Yes, eventually I'm gonna make a hole in that wall, but it's gonna be a mess, right? It's gonna be a mess, not practical, not efficient. So I picked the wrong tool. So it depends when it comes to computer science, it depends what you are trying to do. It depends on the job you're trying to do or the problem you're trying to solve, then you pick the programming language. For example, if you're trying to make a website, then the tool is HTML for structure, CSS for style, and then JavaScript for under the hood, like functionality. Like there are some websites where when you click a button, it does some functionality. For example, upload. When you click the button upload, under the hood, behind the scenes, there is a process that starts running. When you click upload, a process starts running and uploads your selection into some database somewhere. So that's a functionality behind the scene. Another example would be is to do a game. In order to do a game, I don't pick HTML and CSS and JavaScript. JavaScript is not as fast as other programming languages. Anytime you want to do a game, you need to think of speed. Right now, if you download an application, if you download a game and you start that game and then you choose campaign, I want to start the campaign, and then you start training, learning about the game, and the match starts, and then you notice some lagging or some delay. There is some lag in the game. The first impression would be, oh, this game sucks, I'm not going to play this game. Or imagine you're playing multiplayer and then there is a lag. You open your scope, the enemy opens his scope, you click that button and it doesn't shoot. Then 2 seconds later, it shoots. But 2 seconds later is a little late. Your enemy kills you. Again, the first impression would be, no, I'm no longer going to touch this game, and you're going to install it. So if you're trying to develop a game, you need to think of speed. In order to gain speed, you need to pick a fast programming language. And a fast programming language, if you go back to my paint from last session, a fast programming language is the language that is close to the machine and not to the human, right? So if I pick a programming language that is close enough to the computer, that means its execution is going to be very fast. So there is no lag or no delay. All majority, or maybe, yeah, I can say majority of games, they use C++. C++ is, sorry about that. C++ is based on C. So now we are learning C, and then there is C++, and then there is C sharp. Actually, these are the opposite. Let me, boom, boom, boom. C is the lowest in comparison to the 3 ones I'm gonna type. C is the lowest to the machine, then there is C++, then there is C sharp. C sharp is very easy to the human being, but it's slow to the machine. C++ is harder to the human being, but faster to the machine. C is harder for the human, but faster to the machine. The majority of games use C++ and not C, because C++ has the concept of object and classes. So it's called object-oriented programming. Object-oriented programming means the code revolve around objects. Why? Because everything around us is basically objects. A table is an object. Every object has characteristic. A table has a height, a width, color. It has some characteristics inside that object. Some objects have other objects in them. For example, a car is an object. It has a type, it has a size, it has an engine, it has many objects inside that object. So C++ is an object-oriented programming, and it's very low to the machine, so it's very fast. So back to the, let's get back on track. There are 700 programming languages. For Visual Studio, this shows all the programming languages that Visual Studio supports. Also, if you don't find anything, if you're missing what we are trying to do, you need to download it, right? It's missing a package. So you go and hit this button and then go choose what I'm about to choose, and then it will download it to your Visual Studio. So in my case, in our case, if I filter what I'm trying to create, I'm going to create a program, not C sharp, not the rest. I want a C++ project. I choose C++. Which platform I'm targeting? Am I building an Android application? Am I building an Apple application? Linux? No, I'm building a Windows application. I choose Windows. On Windows, what are you trying to target? Are you building for desktop or mobile or a server? Which machine are you trying to target? So in my case, in our case, we are targeting desktop. We are building desktop applications. So when I filter by those settings, I have these options. In our case, I want this wizard. I want to go through a wizard so that I can choose what else I want. I go ahead and hit next. Then it asks me, okay, what do you want to call it? In our case, I'm going to call it my first program. For the project name, my first program. Location, where would you like this project to live? I'm gonna hit browse, and then I'm gonna say desktop. In your case, create a folder and call it intro to C. For example, if you wanna categorize it, homeworks, or just intro to C, and then inside intro to C, create another project, call it homeworks. In this case, it's not a homework, it's just a practice. It's just my first application. So I'm going to call it my first application. And then I'm going to choose this. I'm going to say select folder. Boom. So now my project is going to live at desktop, intro to C, my first project. And I would like to place both solution and project in the same directory. I don't want them to be split in the two different folders. I always want to put everything in one place. Then I hit create. Then I have this dialog or this page, and it's going to ask me, hey, what would you like to further do? In my case, I don't want to do anything. Thank you for your help. I just want an empty project for now. Okay, I hit OK. Now it opened. It opened my Visual Studio. Let's this go away because I want to show you. So this is Visual Studio. Here I have notifications. If I open notification, it tells me there's an update. In any case, at any time you see there's an update, you always want to update. There is eventually, Visual Studio is a huge software. There's always some bugs or errors or some unexpected behavior, weird behavior that happen. So they are always working on it and they are always updating it. So you always want to update. For now, I'm not going to update just not to waste your time waiting for the update to install. I'm going to do it after the session. But please, anytime you open this Visual Studio and you see a notification for an update, hit update. Click on it. So back to this. This is Visual Studio. I have it as dark mode. Now, how to revert it back? I think options, color theme here. So I can put it light. So now it's light. I like it as dark theme. So if you like it dark like me, just do it dark. There's a middle one. There is one I think called the blue, which is like half. I think this is white and the rest is black or the opposite. So in my case, I opened this Visual Studio. Now let me tell you about Visual Studio as is before I take you over the functionalities of Visual Studio. What is Visual Studio? This is a question, for example, you might see in your test. What is Visual Studio? Visual Studio is called an IDE. An IDE. Visual Studio is an IDE. What does IDE stands for? IDE stands for Integrated Development Environment. Okay, well, what does that mean? That means it's an integrated because it has multiple things combined together and provided to you through this interface. Development, because it develops, you develop stuff, and it's an environment. Basically, it's a place, it's an environment where things are integrated together for you in order to develop things. Now, Visual Studio is not the only IDE. There are many IDEs. Oh, again, it all depends on the tool. Mhm. It all depends on the tool. Visual Studios, yes, supports a lot of programming languages, but maybe it's missing one programming language. Let's say it's missing JavaScript. If you need to develop using JavaScript, you need an IDE for JavaScript. An example would be Eclipse. You know, there is Visual Studio, there is Eclipse, there is one called Xcode, there is one called NetBeans. For example, on Visual Studio, you can develop Android applications, but there is a IDE specific for Android, specialized in only developing Android application, and it's called Android Studio, and it was made by Google, right? Visual Studio is made by Microsoft. So this is an IDE. What are the things that are integrated? The things that are integrated, mainly three components. You mainly have three components in any IDE. You have one, two, three. You have an editor. You have an editor. You have a compiler, and you have let's call it syntax highlighting. And this is intelligent. It's not dumb at all because it tells you what's wrong with your code. So any IDE has these three components. It has an editor, it has a compiler, it has syntax highlighting. I will go again back to this after I set up my first program. Okay, because I don't want to just talk or write about it. I want you to see it. So back to Visual Studio. I'm gonna go ahead and create my first ever uh, uh, program. Notice here, Solution Explorer. If you don't see this in your Visual Studio, you go to View, and then you click Solution Explorer. Remember version control? This is Git. This is how I connect my project to a remote host. So view Solution Explorer, and you're gonna see this, and you wanna pin it. You wanna click this pin to keep it on the screen, and I usually put it on my left side. You're gonna see all these different sections. These are just folders to organize your code. So some files go in header folder, some files go in the resource files, some files go to the source folder. For example, let's say you have an application that has 10 screens, right? You don't want to put you definitely don't want to put the code for all 10 screens in one file. First, you're gonna put you want to be organized. You want to put each page, each code for each page in its own file, and then you're gonna call that file. You're gonna call it main page, or profile page, or user page, or I don't know, weapons page, cars page, maps page. So you're gonna have, for each page, you're gonna have a file that is called the same, reflects its reality. Then you're gonna also want to organize them. For example, there is a front end and there is back end. Also, there is database. So in any, let's try to find an image, because an image is of 1,000 words. So front end versus back end. Front end is everything you see in the app as a user. Hmm, let's find a better image. That's not what I'm looking for. Not just like that. Some better things that illustrate front versus back. Huh? Yep, yep. So everything the user sees is front end. Just like this iceberg, you as a human, you see this portion, but under the hood, there is much more things. Mhm. So if I go, for example, to Visual Studio, there is things that I see as a user. I see blue, I see black, I see buttons. This is the front end of Visual Studio. Then there is back end of Visual Studio. So remember how we split each page into files? Then you split files that are related to the front end different than in a different folder than the files that are in the back end. So if I'm gonna go over it again, let's say I'm gonna have three folders here. I'm gonna have front end, I'm gonna have back end code that is related to the back end of the software. And then I'm going to have a folder that is called resources, for example, images that I use. For example, you see this icon, this is an image, right? And then in code, I say, hey, button, use the image that is called X in folder Y. So I'm going to have a folder that's called resource file. And then I'm going to have, for example, another folder called database. Now, if I expand front end, I'm going to see all the files related to the front end. All the files related to the front end means all the pages on the front end, all the pages that the user sees. So this is a place where you organize. In our class, I'm gonna click on source file because everything you're gonna do is under source file. I'm gonna right click on source file and I'm gonna say add. For them in for the whole semester, you're gonna always work with one file. In this semester, we are not going to work with multiple files. So every time you create a project, you can say add a new item and it will open a dialog. It's going to ask you, hey, what would you like to add? You're asking to add an item. Do you want this? In Visual C++, what are you trying to add? We always want to add C++ file, which is .cpp, means .c++. I select this one and I give it a name. And notice the file is going to be living with the same project. It lives under the project. So if I go to my folders and I go to that directory, if I navigate to the directory, I'm going to find this file I'm trying to create. So you always want to give it the name main. So main. And then I say add. So I added a file. This is the first file and it's empty file. There is nothing in it. So I can start typing. So this is an editor. This is an editor. This gibberish was detected by the syntax highlighting, the intelligent syntax highlighting. And this is specific to the programming language. Every programming language has its own rules, its own grammar, right? Like right now in English, there is a grammar for the language. I can't say I is like I is Professor Khalil. Why? Because this is not the right grammar for the English language. So if Visual Studio was supporting English language, I would see a red line under is. And if I hover my mouse under the line, it's going to tell me, for example, this is saying, hey, I'm expecting a semicolon. So if I hover my mouse in a parallel universe where an IDE supporting English language, I'm going to find a red line under this, and I'm going to hover my mouse, and it's going to say, hey, you can't use is after an I. You have to use am. I am Professor Khalil. So every language has its own rules or own grammar. So remove this. If I hover my mouse, it's going to tell me, hey, the grammar of this language you chose, which is C++, does not allow this. There is no word that go by G, P, C, V, P, C in C++. And that was detected by this intelligent syntax highlighting. Mhm. Um, mm, Thinking to go right away. Yeah, we can go right away with writing the code. You can handle it. So What you want to put here is always the errors list. You don't care about anything else but the error list. If there is anything red here, means something is wrong with the code. Now, of course, it's not gonna update right away because like I removed everything, but it still shows me errors. You want to disable warnings, disable messages, and just keep errors. We don't care about the rest. Now, why this is not up to date? You can right click on my on your solution and then you can say build and I'm gonna go over what build does. If you build, now there is no errors. Mm, There is an error. What's that error? Maybe we can type. Maybe when I type something, it's gonna go away. Forget about this, but always keep the errors in front of you. Now, uh, before I start writing some codes, I want you to select debug and then x64. So there are two main configurations. There is debug configuration and there is release configuration. Release means out of this code, build me one executable file that I can run and not worry about debugging it, not worry about going through its code and watching it execute. I just want to execute it. Debug configuration means build me this code, but I also want to step through the code. I want to step through the lines one by one. So basically executed in a slow fashion and keep me connected to the code. This is the difference between debug and release. We always want to build as release. So I'm gonna go ahead and to choose to start a hello world application, right? So the basics of any main file, even if I'm not building a program, the basics of the main file, whether it's a hello world application or a game or any type of application, you always want to have this base code. So I'm gonna type include and I'm gonna elaborate on it. stdi. You see this how it opens suggestions for me. This was by syntax highlighting. So part of it, and I'm gonna elaborate on it, is auto suggestion. So it auto suggests for me. It tells me, hey, are you trying to do stdarg? No, not standard argument. I want standard io.h. This statement is called a preprocessor directive. Preprocessed directive or preprocessing directive, you can call it whatever you want, but it's a pre, meaning before you build the code, I would like you to use this file. So in any programming language, there are things for you that are provided for you instead of reinventing the wheel. For example, in order to display to the screen, you don't have to write a code that communicates with the CPU and then the CPU picks which channel is the screen on, and then through the channels you have to type 10s, 10s, 1001 in order to be sent through the wire to the screen, and then tell the screen, hey, when you receive this sequence of ones and zeros, convert them to this text and then go to this pixel and display, etc. So you don't type all those from scratch. You use already written functionality provided for you, and they are integrated for you, and you include them in your file. So now I'm telling it include standard IO, means standard input and output. This file has code for the standard classic original input and output functionality. So input from the screen to the program and output from the program to the screen. I'm gonna include this, and then I'm gonna say also basic, just memorize it for now. For now, just memorize it. You're gonna say int, let me zoom in actually. You're gonna say int main, man, this bracket, and then you're gonna open curly braces, I'm gonna hit enter. Inside this, go like 3 empty lines and type return 0. This is the most basic software and it's an empty software. What is this is a function, and we're gonna go over it in chapter 7, I think. Was it 7 or 5? I think there is a chapter that called function. This is a function, and it's a main function. Every program in C++, any solution, any project that doesn't have the function main, it will not execute. It will not execute because it was missing the main function. The main function is the entry point, is the starting point of any program, any C++ program. So in my program here, I added a file and I told this file, hey, you have a method that is called main. Now, when I run my program, it's gonna know that this is the starting point. This is where I start from. So now when I run this program, it's gonna start and do nothing. Why? Because the method is empty. There is nothing. There is no instructions. There are no statements. Return the value 0. This int main, when it's done executing, it must return a result. Every method, some methods do not have to return a result, but main, according to the language, the C++ language, it has to return an int. It has to have this specific syntax. It has to return an int. Int stands for an integer. So this portion of this line, this portion means what is this function about to return or result? What is the output of this function? The output of this function that goes between these two curly braces is an integer. The name of this function is main, and this is the parameters list, and we're going to go over them in chapter 3. So here I'm telling it to return just anything. Return this value. I can return this value, this value, this value, anything. In my case, I'm just going to say return 0. Now, if I click this, it's going to run my program. Boom, run. And notice it does nothing. There is nothing. So this is like bunch of Windows stuff. Windows is telling me we ran this process and it finished, it exited with code 0, it's done. To automatically close the console when debugging stop, enable tools, da da da. So if you want this to automatically close when the function is done, you can go to the settings. Otherwise, press any key to close the window. So I'm gonna go ahead and press any key. Boom. Oh, I didn't select it first, so now. So it's done. So what happened exactly when I clicked on this? Well, before we go over this, at this point, I'm going to show you what I meant by an editor. So an editor is a place. So editor. An editor provides many features that make it easier for you to write and manage your code and text, basically, because your code isn't text. You can expand and collapse, for example, different codes. So you see this plus minus, this is provided by the editor. This whole thing is an editor. Notice how it has numbers of lines. It has this functionality. Let's say I have another function. Let's call it the row. Let's call another function select. So notice I have lines, and if at any point I'm working only in draw, I can collapse just so I don't see noise in front of me. I can collapse and only work in draw. If I'm done with draw, I can collapse and then expand select and start working on select just so I am focused. So this was provided by the editor. Also, the editor provided me with colors. Notice the function name is always in yellow. The type is always in blue. Any code in return is a keyword, is a reserved keyword. So it's all reserved keywords are pink. Any literal is green. This is called literal, means literally 0. It's literally 0. It's the value 0. Return the value 0. not not return nothing, because zero means something. It's not just nothing. Zero means the value zero. Like right now, me as an object, how many apples I have? I have apples equal to the value zero. The computer doesn't know what's nothing. I have nothing. Well, what do you mean by nothing, right? So zero is an actual value of the value zero, just like negative one. So zero. So in this case, I'm telling it to return zero. Every statement in C++ must end in semicolon. Semicolon is telling the CPU that, hey, this statement is done. This is one whole instruction. So I can have this on separate lines, and it will still execute. So this, there is no semicolon. So this has no semicolon. This is semicolon. So from the beginning to the semicolon is one instruction. I can now run, and it will run. Boom, it ran. Enter to close. So what is an editor? Editor provides you many features. You can expand, collapse. You can do find, like find stuff. Like I can right click and then go to definition where it was created. In this case, it's created here. But sometimes you're gonna see function written in one place and used in another place. So from the other place, you can right click and select view. Let me see my Zoom really quick just to see how, where are we with the time? I can't see. Hmm, I can't see how long I've been in this meeting. Yeah, I don't know. Maybe 30 minutes? Yeah, I can't see. Hold on, bear with me. Hmm, close. Meeting info. So meeting info still has nothing. Hmm. Close. I'm not trying to waste time. How to know meeting length, length, meeting duration, and show meeting duration, connected time. Da 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 la 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 la. Show my meeting. Okay, never mind. I can't find it. Anyway, I'm gonna assume half. I'm gonna assume uh, 45 minutes, between 30 minutes, what I think, and the session. So 45 minutes. We still have 15 more minutes. For this 15 more minutes, we want to finish what is meant by this and the sequence of the compiler. So again, what is an editor? You can go to, it divides you these colors, it divides all the things that make you help, that help you read code, read text, basically. Imagine this is in a Word document. Everything is going to be black. You're not going to notice which is the function, which is the value. Um, what else? Also, other stuff you can see once we put codes in it, other stuff will be colorized, such as like comments. You know, this is a comment you add forward to forward slash. This is a comment. Means this will be ignored by the CPU. When the CPU or when the program sees this instruction, will ignore it. Means there is no code here. It's just a comment. It's just a text for the user, for me as a user, as a developer. Um, there's also some personalization in Visual Studio where you can set the default color for each type. For example, for if it's an int, I want it to be blue. If it's a float, I want it to be different color. Also size. If it's an int, I want it to be of a specific size. If it's different than int, I want it a different size. This is for um, editor. I'm gonna remove what I did. I'm gonna undo what I did, and then I'm gonna go back to zooming in. Now, the most simple program is a program they call it Hello World. We call it Hello World because it is the first program where your code is telling like hello to the world viewing it. In C++, the statement that displays the stuff on the screen, which is written and provided in this file, is called print. And notice how IntelliSense, which is called IntelliSense, the intelligent, this intelligent syntax highlighting in Visual Studio is called IntelliSense. So it suggests, are you planning to do printf? I can click tab and it will complete it for me. So printf, what are you trying to print? I open a braces or yeah, braces, and then I give it double quotation. So one for the start and one double quotation for the end. And notice it tells me, it's helping me like what to write here. It tells me this int printf, this printf takes a constant char format. So what are you planning to display? I'm planning to display a sentence. I want to display just a string. In this case, it's called hello world. And then I want to not forget the semicolon. If I don't put the semicolon, it's gonna confuse it. It's gonna say there is an error. Do you want to use the last build? No, you always want to use the current build. You always want to build what's in front of you so that it doesn't get confused. When you hit no, I don't want to run previous build, it tells you expected a semicolon at this line at this file. You can double click on the error and it will take you to it. You can double click again. You see these both are for the same place. So here it's saying you expected a semicolon. The program is the Visual Studio is telling me, hey, something is not right here. I'm expecting a semicolon. Is this what you meant? Then I can go and say, yes, this is what you meant. Now this semicolon belongs to this statement. Then there is another statement. Notice how I can put everything in one line. Now it's still a valid program. I can put each word in on a line. Oh, not with strings, sorry. Strings, no. So I can do like this, and then this, and then this, and then this, and it is valid. If I run, it's gonna print hello world. You see it at the very beginning. So congratulations, this is your first program. I displayed hello world on the screen. If I hit OK, I can get rid of those by typing a new line. So I want a new line which is \n means a new line, because if I type n, it's gonna display the letter n. In this case, I'm not gonna display n. In this case, I'm telling it escape the rule, because this is called escape sequence, and we're gonna learn about it. So escape the rule and do this command. The IDE will learn that the N stands for a new line. So new line, another new line, display hello world, and then new line, a new line, a new line, new line. So 6 new lines in total. If I start now, see there is 2 here. So it displayed new line, then the sentence, then a new line, a new line, a new line, a new line, and then whatever Windows wants me to see. So what happened? What happened between well, we can go over them in the chapter. I don't want to move fast. I don't want to load you with stuff, but this is a hello world application. Now you know how to build your own program and display whatever you want on the screen. Homework one will revolve around creating your own software and displaying some stuff on the screen. In chapter one, which is next week, we're gonna go over sorry, we're gonna go over between what happens between writing text and the clicking this button. When I click run, what happened exactly? Who took my text and what did it do with it and how did it know to build a program that does these instructions? So we're gonna go over it in details. What else do you need to do to know about Visual Studio? Yeah, the compiler. We can go over it in steps, which is the compiler is what takes your text and converts it, let's say, or translate it or transfer it uh, to a program, to an executable file. This is what the compiler does. So now you know what is syntax highlighting, you know what's an editor. A compiler is uh, if I want to put it, if I want to put it in in a small sentence, uh, compiler just created is created or not created. The compiler creates your executable program. So you see all these included libraries. The compiler will go and link those libraries into your file, and in order to have a final executable program, there is another utility called linker must combine all these object files. So there is an object file here with your object file. It links them together. It combines them together, your code with the library functions that are needed. So in this case, only this is needed, not all functionality in this file. Uh, and it will build the program. So you can think of it as having all the necessary steps or blocks to build the house. The compiler the compiler prepares those blocks, and then the linker puts them together, sticks them all together to finally create the house. Once this whole process is done, then we have this executor program that executes in front of us, that starts. In this case, it's just a program that displays stuff, but imagine it's a program that asks you to enter some values. For example, it asks you to enter two numbers, and then the program will display the result, the sum, the addition of those two numbers. So it's an interaction, input and output. This is how it's done. So hope you guys enjoyed this session. So please let me know if you don't have Visual Studio. Let me know or let help desk know. Install it and then go over this session. Thank you for attending and good luck. Talk to you soon.